I welcome you to week 6 online facilitation. I will be taking you PHY 205, Introduction to Space Physics. Today, we will be looking at Module 3, which consists of rocket engineering, space exploration, and space law. Now, Unit 1, rocket engineering. Let's introduce this. A rocket is a self-propelled device that carries its own fuel as well as the oxygen or other chemical agent needed to burn its fuel. So a rocket carries its own fuel and also its own energy, oxygen, and any other chemical agent needed to burn the fuel. Most rockets move by burning their fuel and expelling the hot exhaust gases that result. The force of these hot gases shooting out in one direction causes the rocket to move in the opposite direction, thereby obeying the third Newton's law of motion. I hope you remember that the law states that for every action, there is an equal but opposite reaction. So that is one of the application of the third law in rocket engineering. A rocket engine is the most powerful engine for its own weight. Okay, now what are the objectives of this unit? At the end of this unit, all of you are expected to be able to define a rocket. That is one, to define a rocket. Two, you should also be able to explain the principles of rocket propulsion. The principles of rocket propulsion. Third thing you are expected to know is to be able to state the Newton's third law of motion and derive the rocket equation. Four, you should be able to explain the Tolskovsky's rocket equation. Five, you should also be able to explain the principles of the thermal rocket. The principles of the thermal rocket. Okay, so let's start with the principles of rocket propulsion. What are the principles of rocket propulsion? Human development has always been closely linked with transportation. We know that we need to move from one place to the other. The domestication of the horse and the invention of the wheel had a dramatic effect on early civilization. At that time, they needed a horse to move from one place to the other. Most of the past millennium has been strongly influenced by sailing ship technology, both for war and commerce. In the 20th century, motor vehicles and aircraft have revolutionized transportation. Rocket propulsion is the essential transportation technology for this rapid growth in human communication and exploration. From its beginnings in ancient China through its rapid development during the Cold War, rocket propulsion has become the essential technology of the late 20th century. Newton's third law and the rocket equation. As we have seen, the rocket had been a practical device for more than 1,000 years ago, before Tchaikovsky determined the dynamics that expand its motion. In doing so, he opened the way to the use of the rocket as something other than an artillery weapon of dubious accuracy. In fact, he identified the rocket as the means by which humanity could explore space. The rocket experiences a conditioned propulsive force, a continuous propulsive force. So its flight will be different from that of a cannonball. We know cannonball. In fact, while a cannonball is a projectile, the rocket is really a vehicle. Shostakofsky's rocket equation. Shostakofsky was faced with the dynamics of a vehicle, the mass of which is decreasing as a jet of matter is projected rearwards. As we shall see later, the force that projects the exhaust is the same force that propels the rocket. Are we together? Now, it partakes in Newton's third law. Action and reaction are equal and opposite, as I said earlier, where action means the force. The accelerating force is represented using Newton's law. That is the second law, where force is equal to the product of mass and velocity. Now, in this case, is the effective exhaust velocity. So the energy released by the burning propellant appears as a fast-moving jet of matter, and a rocket accelerating in the opposite direction. Newton's law can be applied to this dynamical system. Okay? And the decreasing mass can be taken into account using some simple differential calculus. Don't forget your differential equations, differentiation and integration. You will need it as you proceed with your BSc physics program. The mass ratio, often written as ROA, is just the ratio of the initial mass, m0, to the current mass, m. As you can see in the equation below, R equals to m0 over m. Now, the thermal rocket. The rocket principle is the basis of all propulsion in space. And all launch vehicles, the twin properties of needing to external medium for the propulsion system to act upon, and no external oxidant for the fuel, enable rockets to work in any ambient conditions, including the vacuum of space. Okay? The thermal rocket is the basis of all launchers and almost all space propulsion, although some electric propulsion uses a different principle. Now, the thermal rocket motor is a heat engine. We know heat engine in thermodynamics. It converts the heat generated by burning the propellant, fuel, and oxidizer in the combustion chamber and into energy of the emerging exhaust gas. Okay. The momentum carried away by the exhaust gas provides the thrust which accelerates the rocket. Are we together? The momentum carried away by the exhaust gas provides the thrust which accelerates the rocket. As a heat engine, the rocket is no different in principle from other heat engines, such as the steam engine or the internal combustion engine. Okay? The conversion of heat into work is the same, whether the work is done on a piston or on a stream of exhaust gas. That is good. So I hope you understand the thermal rocket and how it works. And the basic configuration of the thermal rocket. A liquid fuel rocket engine consists of a combustion chamber into which fuel and oxidant are pumped, and an expansion nozzle which converts the high pressure hot gas produced by the combustion into a high velocity exhaust stream. Now, it is the expansion of the hot gas against the walls of the nozzle which does work and accelerates the rocket. Okay. A solid fuel motor operates in the same way the normal car, conventional cars we drive, operates in the same way, except that the fuel and oxidant are pre-mixed in solid form and are contained within the combustion chamber. Normally, the combustion takes place on the inner surface of the propellant charge. The exhaust nozzle is identical in form to that in the liquid fuel motor, and the principles of operation are the same, virtually the same. In this module, in this unit, we shall make little distinction between the solid, liquid, and liquid fuel variant of the thermal rocket motor. So the thermal rocket is subdivided into the solid fuel and the liquid fuel. Okay, so we'll see that later. Now, this is the diagram. This is the diagram of the liquid and solid fuel. We can see in the liquid fuel rocket up there, we have the fuel and the oxidant in that chamber, the combustion, then hot gas at high pressure is released, then expansion takes place. Then high velocity exhaust is achieved. Now, in the solid fuel rocket, see the diagram there? There's a propellant, there's a combustion, there's a propellant. Now, that's in between the two propellants, we have the combustion. Now, from there, hot gas is released, then expansion takes place, and high velocity exhaust is attained. So, today, your self-assessment exercise is this. You should briefly discuss the principles of rocket propulsion. That is all. To do that yourself. If you need more clarification, the course material is there. Check it and be guided. And in conclusion, we have learned that rocket-propelled vehicles are the essential transportation technology for this rapid growth in human communication and exploration. Additionally, the thermal rocket is the basis of all launchers and almost all space propulsion. Now, summary. We have learned that a rocket is a device which propels itself by emitting a jet of matter. Now, the momentum carried away by the jet results in a force acting so as to accelerate the rocket in the direction opposite to that of the jet. Now, a rocket carries both its fuel and its oxidizer, we have not forgotten, and needs no intake of air to operate. Okay? A rocket can function in a vacuum and in fact works better because air pressure retards the exhaust and reduces the thrust. The rocket principle is the basis of all propulsion in space and all launch vehicles. All these are summaries of what we did. The next one is the thermal rocket motor is a heat engine. It converts heat generated by burning the propellant, fuel, and oxidizer in the combustion chamber and into energy of the emerging exhaust gas. And then a liquid fuel rocket engine consists of a combustion chamber into which fuel and oxidant are pumped, and expansion nozzle which converts the high pressure hot gas produced by the combustion into a high velocity exhaust stream. So that is exactly what we are looking at today. And I believe you have learned something about rockets. We said we have in the rocket, the thermal rocket, we have both the liquid rocket and solid rocket, fueled rocket. So by next week, we'll continue with space law. So I wish you all the best, and I expect you to read and prepare for your TMAs, your tutor math assignment. So see you next week. All the best.